Introduction. Predictive artificial intelligence, AI, is a rapidly growing field with a wide range of applications across different industries. From healthcare and finance to retail and transportation, predictive AI models are being used to make more accurate predictions and decisions based on large amounts of data. Predictive AI models are trained on historical data to learn patterns and relationships that can be used to make predictions about future events. This allows organizations to make more informed decisions and improve their operations. In this video, we will be discussing the different types of predictive AI models, their uses, and the key challenges and limitations of the field. Definition. Predictive AI models are a type of machine learning that are used to make predictions about future events. They are trained on historical data to learn patterns and relationships that can be used to make predictions about new, unseen data. While there are many different types of AI models, predictive models are particularly useful in applications where it is important to make accurate predictions based on historical data. These models can be used in a wide range of applications such as finance, healthcare, transportation, retail, and many more. In each case, the goal is the same: to use the historical data to make predictions that are more accurate and useful than what we could make otherwise. Supervised learning. Supervised learning is a type of predictive AI model that is trained on labeled data. This means that the model is given both the input data and the corresponding output or label. The most common algorithms in supervised learning are regression and classification, which can be used to predict numerical or categorical values. Some examples of supervised learning algorithms are linear regression, SVM, random forest, neural networks, among others, each with its own strengths and weaknesses and specific use cases. References. Pattern Recognition and Machine Learning by Christopher M. Bishop is a classic book that covers the fundamentals of supervised learning in detail. Machine Learning by Tom Mitchell is another popular book that covers a wide range of topics in supervised learning. Visual examples. In supervised learning, a simple example can be a line that separates two classes in a 2D space. This is called linear classifier. A more complex example can be a deep neural network that learns to recognize images of different animals, which can be visualized as a set of interconnected layers, which are activated depending on the input image. Real-world applications. There are many real-world applications of supervised learning. Some examples are credit scoring, using various data points to predict whether a person is likely to default on a loan. Fraud detection, using transaction data to detect unusual patterns that may indicate fraudulent activity. Image recognition, identifying objects or people in digital images. Natural language processing, identifying entities and sentiments in text. Unsupervised learning. Unsupervised learning is a type of predictive AI model that is trained on unlabeled data. This means that the model is only given the input data and must find patterns and relationships within the data on its own. Some common algorithms in unsupervised learning are k-means and hierarchical clustering, which are used for clustering the data and finding patterns in it. Unsupervised learning is commonly used in clustering, dimensionality reduction, density estimation, and anomaly detection, among others, which all require to find hidden structures in the data. References. Cluster Analysis for Data Mining and System Identification by Janos Abeny is a good book that covers the fundamentals of unsupervised learning, particularly clustering techniques. Introduction to Data Mining by Peng-Ning Tan, Michael Steinbach, and Vipin Kumar is another popular book that covers unsupervised learning in the context of data mining. Visual examples. A simple example in unsupervised learning can be plotting the data points in a 2D space and then using algorithms such as k-means to cluster them. Another example can be representing a high-dimensional dataset in a low-dimensional space, with algorithms such as principal component analysis, PCA, to find patterns. Real-world applications. Applications of unsupervised learning are varied. Some examples are market segmentation, grouping customers with similar buying habits. Anomaly detection, identifying unusual patterns in a dataset. Recommendation systems, suggesting products or services to customers based on their previous interactions. Reinforcement learning. Reinforcement learning is a type of predictive AI model that learns by interacting with an environment. An agent learns to perform actions that maximize a reward signal. Reinforcement learning is mostly used to solve sequential decision-making problems such as game playing, robots control, and recommender systems. Some examples of reinforcement learning algorithms are Q-learning, SARSA, and PPO, which are commonly used in game playing and robotics. References. Reinforcement learning. An Introduction, by Richard S. Sutton and Andrew G. Bartow, is the most widely used textbook in RL. Deep Reinforcement Learning Hands-On, by Maxime Lapon, is another book that covers the topic in detail with practical examples. Visual examples. A common example in reinforcement learning is a game such as chess or Go, where the agent learns to play by taking actions and receiving rewards based on the outcome. Another example can be a robot navigating in an unknown environment. It will learn to move around by trial and error and taking actions that maximize its reward. Real-world applications. Applications of reinforcement learning are diverse. Some examples are robotics, training robots to perform tasks in unstructured environments. Game playing, training agents to play video games. Recommendation systems, recommending products or services to users based on their previous interactions. Finance, trading stocks or currencies in the stock market. Healthcare, optimized treatment plans and drug development. Challenges and limitations. One of the main challenges in predictive AI models is the quality of the data. Poor quality data can lead to inaccurate predictions, which can have serious consequences in many applications. Another challenge is interpretability, which is the ability to understand how a model is making its predictions. Many predictive AI models are considered black boxes, which can make it difficult to understand why a model is making a particular prediction. There are also limitations when it comes to time and resources, as predictive AI models require large amounts of data and computational power to train. Additionally, some models may be difficult to scale or maintain over time. Conclusion. Predictive AI models are an important tool in a wide range of industries, allowing organizations to make more accurate predictions and decisions based on large amounts of data. However, it's important to keep in mind the challenges and limitations of predictive AI models such as data quality, interpretability, and scalability. Despite these challenges, the potential benefits of predictive AI models make it a rapidly growing field that is worth exploring further. As the technology and understanding of these models evolve, we will continue to see an increasing number of applications and advancements in this field. In conclusion, predictive AI models are powerful tools that can bring significant benefits to different industries, but it's important to approach them with awareness of the limitations and make use of best practices for data management and interpretability.